This video will be dealing with solving quadratic form equations and using the quadratic formula. Quadratic formula is derived from the quadratic equation ax squared plus bx plus c equals 0 by a process called completing the square. We don't necessarily need to go through that process to get to show you how it's derived, although it is interesting and worth checking out. All we need to know is how it ends. It ends at x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, notice that the x is all by itself on the other side of the equal sign. X equals all of that. X is what's being solved for. X does not get put into the quadratic formula. The quadratic formula is filled with only the coefficients a, b, and c. Also, notice that the equation, before we even start, is set equal to 0. That is the standard form, and it needs to be equal to 0 before we can do anything. All of this is based on the equation equaling 0. The x is not put in. All we use are a, b, and c. Now, what do you do with it? Like I just said, we plug in a, b, and c, and then work the numbers. That's it. Any kind of formula, that's all you ever do. Plug in what you know, figure out what you don't. The discriminant is the part under the radical sign, the radicand, b squared minus 4ac, and it just gives you an opportunity to indicate, to predict what kind of answers you're going to have. I'm not a big fan of the discriminant because if you look at the whole quadratic formula, the discriminant is almost the whole formula. I mean, what's left? The negative b, square root, and divide by 2a. So once you have the discriminant figured out, you're almost done anyway, so you may as well just finish. But it is talked about in different circles. So if your discriminant is positive, b squared minus 4ac, if that comes out to be positive, well, there's a positive root of that number, and there's a negative root of that number. So you have two real roots, two real solutions. If it's 0, the square root of 0 is 0, so you're only going to have one real solution. And if it's negative, there are two roots of it. There's a positive root of a negative number and a negative root of a negative number, but we never have a square root of a negative number, so this is an imaginary number, and we'll get into those later. But there will be two of them, so there'll be two imaginary solutions. Two real if it's positive, two imaginary if it's negative, and if it's 0, there's just going to be one real solution. That's it for the discriminant, and that's it for the quadratic formula. Plug in what you know, figure out what you don't. Nothing else to be said. Quadratic form. The quadratic form is an equation that is similar to the quadratic equation but slightly different. Quadratic form equation, the exponent is not necessarily 2 and 1 like it is in the quadratic equation. The first exponent will be twice as much as the second exponent, and you still have a constant as your c term. So if you had ax to the 2n plus bx to the n plus c equals 0, let's say n is 3, 2n would be 6. So that would be ax to the 6 plus bx to the 3 plus c equals 0. The first exponent twice as much as the second. So then you would just substitute any variable you want for the x to the n. Leaving the b alone, you would just substitute for x to the n. Say q. Well, if q is x to the 3rd, then what would x to the 6th be for the 2n portion? X to the 6th would be q squared. So then you'd end up with ax squared plus aq squared plus bq plus c equals 0, a standard quadratic equation. That's all that needs to be done. You just substitute any variable you want, turn it into a standard quadratic equation, and solve that. But the difference is when you solve, you're solving for q, not x. So you then substitute back to what you had to begin with. Remember, x cubed was q, so q goes back to x cubed, and then you finish solving whatever your new equation is. It's much easier to do than it is to explain. Once you get into a few of them, you'll do just fine, and this will make much more sense to you if you look back at it.